This experiment is called disturbing a chemical equilibrium. And so for this experiment, we use the reaction iron-free ions plus thiocyanate, which is equals to iron thiocyanate, which is at chemical equilibrium, as the solution is in an aqueous solution. The concentrations are constant, the reaction goes both ways, and the rate are the same both ways, and there's both products and reactants present, which is all the requirements for chemical equilibrium. This experiment is useful to understand equilibrium because iron cyanate is red and therefore visible when the reaction is at equilibrium, because iron cyanate is always present at equilibrium. It is then also easy to observe the changes in the color when we stress the reaction, which can tell us whether there's been a shift to the reactants or a shift to the products in order to re-establish equilibrium. So the chemical expression is written as it's shown. The constant K is equal to the product divided by the reactant times the reactant. And so for this experiment, it is the concentration of iron cyanate divided by iron-free ions times cyanate, which is also equal to the Q value since it's at equilibrium. And over here is the requirements which are needed for equilibrium. And so in test tube 1, we increased the concentration of iron-free ions by adding iron nitrate. We saw that the solution turned into a darker red. This can be explained by the Chatelier's principle, which states that if one or more factors that affect the equilibrium is changed, the position of equilibrium shifts in the direction that reduces the change. Here, and in this experiment, it's because there's more iron-free ions, so the reaction shifts to the right, which means that more product will be formed, which is the color red, and that's why it turns more red. So the Q value is greater than the K value. And then to get back at equilibrium, there will then need to be a decrease of iron-free ions and an increase of iron thiocyanate. And in test tube 2, we increase the thiocyanate by adding potassium thiocyanate. We saw this solution turning dark red instantly as well. This can be explained by the same way, since there was an increase of a reactant like before, which made the reaction shift to the right, making more product to get back at equilibrium. And here on the right you can see the two different test tubes with the two different solutions. And in test tube 3, we removed all of the iron-free ions with ascorbic acid, which turns iron-free ions into iron-2 ions, and the solution turned colorless because there were no more iron-free ions, so the reaction would only go to the left, meaning that at last there would be no more product left. Yeah, and in test tube 4, we removed some of the thiocyanate by adding silver nitrate, and the silver nitrate formed a precipitate with thiocyanate. The solution then changed color to orange. The reaction shifts to the left to form more of the lost thiocyanate to restore equilibrium. This is also why it changes color from red to orange, because there's less product. Yeah, and as you can see in the bottom, the K value is greater than the Q value, because there's less of the reactants. And then in test tube 5, we increase the temperature from room temperature to 50 degrees, and the solution turned into a lighter red. This can be explained by that there was a shift to the left, because it's an endothermic reaction to the left and an exothermic reaction to the right. And then therefore when we increase the temperature, the endothermic reaction is greater. And then in test tube 6 we did the opposite, meaning that we decreased the temperature from room temperature to 8 degrees, and then the solution turned into a darker red, because then the exothermic reaction is greater. It's greater than the endothermic reaction, and that's therefore shift to the right. Yeah, and on this picture you can see test tube 5, 6, and 7, and you can compare the colors, where and test tube 7 is like used as a reference, since there hasn't been any haven't been added anything in it. Yeah, and then we had another small experiment after the ones with the test tube, and it started with, we poured the remaining equilibrium mixture into 2 cylinders as shown on the pictures, and in one cylinder we would double the volume by adding water, as you can see in the pictures, the one from the side, the one without the water, is a darker shade red than the other, and it's likewise when you're looking at it from the top. And this is because each of the concentration of the element in the water one was halved, which you can see at this expression, which also means that K is greater than Q, because here we have half of the concentration of iron thiocyanate, and which is divided by half of the concentration of the iron-free ions, and half of the concentration of the thiocyanate, yeah, which would then mean that K is greater than Q, which would then also like make a shift to the right, making the solution lighter and more orange.